Hi, I'm Matt Connew. I work, yeah, the. Hi, I'm Matt Connew. I work on CoreWCF and on WCF in the dotnet framework and in the open source. And I'm talking today about how CoreWCF isn't just about bringing over your existing app as is, but you can do some modernizing and improving and adopting some of the new technologies which are out there. So just to go over the agenda today, first thing we're going to talk about is the dependency injection support that we have integrated into CoreWCF. Going to talk about ASP.NET Core authorization integration, the new message queue options that we have to replace MSMQ, and going to briefly touch on some of the things which are coming next in CoreWCF. Okay, so first thing is dependency injection support. So we've enabled being able to pull your service type from DI. So in WCF, you had to have a default constructor, and WCF would instantiate your instance on that based on that default constructor. But now you can have all your dependencies on your constructor and inject into DI, and CoreWCF will pick it up from there. Your iService behavior can also be injected into DI. I'll show you a trick you can do with iClonable if you've got a slightly more complicated scenario, if you need to customize the behavior based on each individual service. And we've also got support for service operation methods can have injection enabled as well. And so to do that, you'll need to make the implementation partial because we have a code generator to backfill the interface. So you still have a method matching what your contract is expecting. And there are two different ways to do that. You can use the MVC core from services attribute, or we have our own injected attribute. Now, the reason why we have our own injected attribute is from services is, as I said, from MVC core. And to be able to use that, you need to pull in the MVC core assembly into your application. And so if you're not using HTTP at all, and like say you're using NetTCP, felt like that just didn't make sense. And we're also bringing in some new features around injection, which I'll talk about later, which would require its own attribute anyway. Okay, so onto a demo. Okay, so here we've got just a simple service. It's an echo service, just returns back the string that you sent. And what we're going to do, first of all, is just add it to DI. So we just do that just with a simple add transient on the type. And now CoreWCF will just pull it from DI. Now, it said you can add a service behavior to DI. And so where you would do that is with a line similar to this, where I'm just adding a singleton, and the DI type is my service behavior, and the concrete type is my service behavior. Let's go look at that my service behavior. I mentioned about the clonable and the iClonable interface. The problem you have is here we just got one service type called service, but if you had service A and service B, then if you were doing any configuration on the service behavior, you'd get the exact same configuration on both of them, and then you can have difficulty having each one have slightly different behavior. So what we've done to address that is we check to see if the behavior supports iClonable, and we call clone on it. So here you can see a simple implementation of clone. And then that allows you to modify the clone on a per service basis, so that's you don't end up modifying the original master one. So here this service behavior has injected into its constructor a logger, and each of the behavior methods, all we're doing is just logging that that method is called, and we're prefixing the log with a logging prefix, which just defaults to the name of service behavior. So if we didn't do any customization, it would just simply say my service behavior add binding parameters called. Now, so what we can now do is we have a extension method on Service Builder where we say configure service host base and you pass it the service type. And that gives you access to the service host base, just like you would have done with the old WCF when you're creating a service host instance. You can modify it. So we're going to go to the behaviors of a description and pull out the my service behavior, and we can modify the logging prefix. Now, because this was cloned, this is not the same instance as you get if you pulled from DI. So if we pull this from DI, and we can actually do that by having code similar to this. After we started a service, we just go to the services and say, get us an IEnumerable of iService behavior. And you have to do it this way because you can have multiple iService behaviors. And if you just ask for an iService behavior, you'll just get the last one added. Whereas if you do an IEnumerable of iService behavior, you get all of them. And up here, we have another one added after it, which is to do with metadata with WSDLs. And so if we just ask for iService behavior, that's the one that we would get. So we have to ask for IEnumerable. And then we use .single to go and get the single iService behavior, which is of type myService behavior. And then we're just going to write out that what the logging prefix is on this one. Now, if we go and test this now, we'll see that we've got demo validate called, demo add binding parameters called, and demo apply dispatcher behavior called. But the myService behavior.logging prefix is still myService behavior on the one from DI because we cloned it and then we modified it in here where we set the logging prefix to demo. And so this is how you can add a behavior to DI. You can set a bunch of defaults that you want across all your services, and then you can use this technique to go and customize the specific behavior, and you still get all your dependencies injected. Okay, so then the next area where we have DI is on, you can add things in on here. Now, a problem we have is this echo method comes from service interface. So we've got the string echo here, and so if we go and add parameters in, it's not going to match anymore. So we have a code generator which goes and backfills that for you. So if we do make this class partial, then we can go and add in a logger in here. And so we can say from services, we want an iLogger of service logger, and then we'll just log the value. And then we can watch that in action by running the service, and then make a client call, and we've logged out that echo hello world was called, and we see that the call was returned. Okay, and then if we go and look at the code here, we can see that we have a way to go get the service provider from the operation context, and this is all the code that we generated to go and get the iLogger that was requested and call the new method. And this method here matches what's expected in the interface, so your program still compiles because you've got a matching interface method. Okay, so that's DI. Now, we've got ASP.NET Core authorization integration. The support is currently only for HTTP. We do plan at some point to add support for non-HTTP protocols, transports, but there hasn't really been any demand yet, so it hasn't been a high priority to fill that gap. But it's on the backlog of features to do. So all your configuration of authorization is will be done in ASP.NET Core. So you only need to learn how to do it the one way, and you don't have to have a different way to do it in CoreWCF. We have support for the authorization attribute, so that's the same attribute that you would use if you had a Signal R or an MVC application. We only support the policy property. You can't specify roles or authentication schemes. And we don't have support for the allow anonymous attribute. The way how you would achieve that with CoreWCF is you'd add a second endpoint onto your service using the anonymous client credential type or client credential type of none. And then when a call comes into a method which is requiring authorization, then it will reject the call. But if it comes into a method which doesn't require authorization, then the call will go through. So let's see a demo of that. So first thing we need to do is we need to add all the code for ASP.NET Core authorization. And so to do that, so first we just add authentication using a JWT bearer type. And the Duende, who provide an identity server commercial product, have a demo endpoint that, with pre-known credentials, secrets that you can use to be able to test the scenario. So that's what I'm using here. And then when I add authorization, the default policy is that you require an authenticated user and require this assertion code to return true. And so what we do is we go through the claims and we look for the scope claim, and the scope is space delimited. So we split that, and then we look for the scope of API. And if it doesn't have a scope of API, then we reject the call. And then to use this on the service, we just put the authorize attribute on it. And there's one more change we need to make in the program. We need to modify our binding. Our binding currently is a basic HTTP binding. So all we do is say binding.security.transport.client credential type is inherited from host. So all this is an existing enum value. So on WCF, this had meaning that IIS was configured for any authentication you needed, and so just leave it up to IIS to make sure things are authenticated. And so we're doing a similar thing here where we're saying we're just going to leave it up to ASP.NET Core to make sure it's authenticated. All we're going to do is when you get to the calling the service, we make sure that that happened, and if it didn't, we reject the call. So now, if we want to see the evidence of that, we can actually extend our echo method a little bit more using DI. And so we actually support inverts technically not in DI. We support injecting HTTP context. You can also do HTTP request and HTTP response. And so we go and grab that and inject it in there. So here we are getting the user claims principal, and we're getting the claims, and we're just concatenating a string for it, and we're going to log that information. Now on the client side, again, we're using this demo endpoint. So the code simply goes and gets the discovery document to get the endpoint address, and then it uses this client ID and client secret on the demo endpoint, where the client ID is M2M and the secret is just secret. And this will return us a token, which is valid for, I believe, an hour. And then we just add it as a custom HTTP header type bearer, and then that gets sent. So we can see what it looks like. When we call the service, you can see that we're now logging out principal has claims, and it lists out all of these claims. Now, if we want to use a specific policy, we need to be having policy based on the incoming claims for this demo. And so I'm just going to use this one where the client ID, and we're going to have a requirement on this client ID. So how we do that is when we are configuring the authentication, we just add options.add policy, and we call it has expected client ID is the name of our policy. And we're going to say we're going to require a claim with claim name of client ID, and the allowed value is only going to be M2M. And then what we can do is go over to our service here, and we can add an attribute saying that the policy has expected client ID applies to this method. But now, as we're using that client ID, client should be able to call it and successfully get a response. But what we can do to see that this is working is they actually have a second client ID, which returns you a token which has got a lot shorter lifetime on it. Other than that, it's identical. And so if we use that instead, we get a security access denied exception because the client ID now doesn't match. Okay. So that's quite a powerful thing that you can now do. We now integrate into the ASP.NET Core authentication mechanism, and you can use all the new OIDC and OAuth2 authorization and authentication flow. Okay, so the next thing is message queue options. So CoreWCF only has MSMQ, and when you're running in the cloud, you need to stand up a whole VM to run it, and the high availability scenario is kind of complicated setup, and all your clients must be running Windows. And with CoreWCF, we've had as a primary tenant is that whenever possible, we need to supply solutions which are cross-platform. So an example of that is while we've brought over net-named pipe, we wanted to get a cross-platform equivalent, so we've actually introduced a Unix domain socket binding, which gives you equivalent capabilities on Unix and also works on Windows as you had with net-named pipe. And so we're taking the same approach with queuing. So there's actually currently 4 available and the 5th one about to be available, different queue bindings. So 3 of them are provided by CoreWCF and 2 are by platform owners. So one's provided by CoreWCF is AMQP, and that's based on RabbitMQ libraries. We've got Kafka implementation, which uses Confluent libraries to communicate. And then we have MSMQ. That's currently in preview. It is functional. We need to remove a dependency on a third-party library which isn't suitable for support. And so once we've done that, then it'll come out of preview. And so the two provided by platform owners. So AWS has packages and a binding to work against their SQS product, and Azure AQS support is coming very soon. And so those NuGet packages will be provided by Azure. Okay, so quick demo of that. So for an AMQP service, so all you do is you have to add queue transport on there, which brings in our generic queue hooks into ASP.NET Core. And then the bindings can then hook into that for providing our actual concrete implementation. And then here we've got the RabbitMQ binding, and we've got two queue configurations. There's a classic one, and then there's also the new Quorum one. So anyone who's used to using RabbitMQ should be familiar with those two different terminologies. And we just pass the credentials for the user. I have a Docker container running locally with RabbitMQ running on there. And then I just add a service endpoint, and this is the details of the Docker container. And so this is a queue name and key name. And then on the client side, just as simple, I've got channel factory with a RabbitMQ binding, pass it the same endpoint address. And this time the credentials go in via channel factory.credentials instead of on binding, because we've got a place to provide client credentials on the client side. And we just create a channel, call open, and we call the method send hello. So all we do with send hello is, here we're using, instead of a from services, we're just using the injected attribute instead. And we just log out that whatever name was passed says hello. Let's take a quick look at what that looks like running. Service running. And then the client sends a message and says, Matt says hello. You can see it's very quick to be polling and picking up the next message. Okay, so what's coming next in CoreWCF? We're very excited about the new keyed dependency injection. We've got a few places we're going to use it. We're going to support adding from keyed services in the operation injection. We're going to add support for iService behavior keyed by the service type. So what you do is you'll add your iService behavior of your concrete type, and the key will be type of your service type. And that way, CoreWCF is going to go and request all the iService behaviors registered against that key. And we're also adding the ability to inject message properties into a method call. So one example is there's a remote endpoint connection message property. And so you'll be able to ask for that as a pass-in parameter, and it'll do all the work of going to your operation context, .current, .incoming message properties, go get, check if message property is there, cast it the right type, and pass it into your method. So it takes a bunch of boilerplate code out for you. Reliable sessions is on its way. It's a big feature. I've got a lot of it implemented now, but still a little bit more to do. And we are committed to getting AOT support fully working. So we need code generators to remove some of the runtime reflection invocation work. We've got one code complete but not merged yet, which is for invoking the operation. And so we've got a couple more that we need to do, and then we'll make sure that and start running tests to make sure that the whole end-to-end AOT scenario is working. So those are just the short-term deliverables we're working on. We've got lots more coming longer term, but don't want to be talking about stuff without a committed plan yet for exactly when it's going to happen. Okay, and here's the website you can go to go read more about CoreWCF. That's GitHub repo, and thank you very much.